Hello and welcome to another tutorial. So we're going to be continuing with the Spaceship project in this one. And the focus this time around is going to be a few sort of quality of life improvements, a bit of polish and updates there. And this is something that I do recommend when you're working on projects, in particular larger ones you might be working on for a while. It's good to take opportunities regularly to stabilize the project, to make sure everything is running and working nicely, and in particular doing that if there's then a bunch of bigger things you've got planned, doing that stabilization beforehand can really make sure that you're moving from a good solid base. So that's going to be our focus today, some quality of life improvements in general, stabilization and refinements there. So the first thing that I want to be doing is tackling a couple of stuff we currently in this for the player, we actually have done a bunch of modifications to the player character motor. And while that is perfectly valid, they're reasonable modifications that we've made there. What it means though is that we have this situation that if we try to update this, it actually gets trickier. So we've already got inheritance supported. The player character motor already inherits from this character motor one. So this is a case where what I would do is, this is a good scenario to set up another child class. So with inheritance, we're not just restricted to one thing inherits from one other thing, and that's the level of the depth of it. Our inheritance can have our character motor, then our player character motor, then our customized player character motor for this. So we can have multiple layers there of the inheritance, and each layer gains the things from the layer above it that it's inheriting from. So we're going to do that with the character motor here, with the player character motor, just to make it a bit easier so that we're not having to be continually, when we update it, means we just get those updates in there. It's not going to be as likely to cause issues, and it'll also simplify the upgrading process. So what I'm going to do is in the scripts folder here, I'm going to create a new script. Now, naming of this is something that matters and that we need to think about. So it is a player character motor. And I'm going to call this player character motor, and we'll actually go for Spaceship. So that looks good. And then I'll load that up. And the starting point that I would follow for this is I would bring in everything essentially from the player character motor. So I would transfer everything over. So we'll just copy all of this over, because most of this will then end up actually going away. And then what I would do is I would say this inherits from player character motor. Now the advantage of doing that is as soon as I do that, we can see it's going to highlight a bunch of things that are common to both. And so that's going to mean there's a lot of ones here that I can actually remove, which is going to be really handy. So what I would be doing is I would be, this is something where potentially having these side by side may be helpful. So I can see the pair of them and see what's actually involved. The other way that I can go about this is I could take the current base player character motor script, so the actual current one from the template version, and I could replace the one that I've got in here with that. So that's the other option that I've got for this. And that's actually something that I could do. But what I'm going to do instead is I'm just going to look through and see, okay, well, there's some obvious things. So Spaceship to be repaired and repair HUD. We know that that's not going to be stuff that needs to carry over. So the player character motor shouldn't have those anymore. The Spaceship, well, the Spaceship doesn't need the linked camera, doesn't need head bob. UI interactions, that should be in the common one. So we just start going through and removing ones. Things like on move, look, jump, run, all of those can disappear. Now the primary action, there is some customization we have for the spaceship, so we're going to leave that one for now. But in the player character motor, that's where what I would do is I would remove the spaceship logic. So all of this section is spaceship specific, so that would disappear. So it's going to thin down our player character motor a bit. Secondary action is exactly the same, so it would go. Our awake, start, all of those ones are the same. Now update. So player spaceship one has some specific stuff, so we would keep that. But the player character motor, we would get rid of those sections. So that goes away. And what we'll find is the custom version we have will actually be quite short. So late update and update camera, we're not doing anything with those. Same with the cursor lock. So our custom one, really the only things it's got is we've got the update, and then we need to do something with the primary actions here. And this is something where we've got a couple of ways we could go about this. So this is something where there is a modification we obviously need to make to the child class, because this is some common stuff. So we want to be able to go, okay, well, base on primary action. But you'll see we're hiding it. So what we want to do is that primary action one, I'm going to make that a virtual. And then this becomes override. Means it's also a lot easier for us to see what stuff has changed. So this is, again, one of the advantages of using inheritance like this, is we're only seeing what stuff is different. So in this case, the only things that we're handling differently is we're overriding that on primary action. We're still running all of the base logic, but we're doing that just so we can substitute in our own little bit of logic. And we're overriding update, again, so we can insert our own little custom extra bit of logic. And that's how we tend to often use inheritance, is we're either layering in a little bit of extra logic of our stuff, or we might be replacing the existing logic. That's the sort of main areas where we're using it. And it means now our player character motor is much simpler. It's got nothing that's spaceship specific, which means, say we bring in an updated version of that player character motor, that process of bringing it in is now easier. So that's the advantage we get with having inheritance like of this. It means that our process of keeping things up to date is also going to be significantly easier. Now the fun part of, okay, that player, well, they're already linked up. The script's already linked up here, and I've got a lot of bits of data linked up. And so that can be a little bit annoying to try and switch that over. But that's manageable. What I can do, and this is something that I do recommend being a little cautious when you're making changes like of this. So I can make sure everything's applied to the prefab. What I can then do is I can find the prefab here. In the top right, if I click on the three dots, I can switch to debug mode. And what you will notice is then when I come down here to the player character motor script, I can actually select a new script. So I can just bring this across, and the advantage this has is that will then switch the class, but it doesn't get rid of any of the data. It's able to do that switch. So when I go and select the player here, you can see it's now the Spaceship customized version. So it just makes that a little bit easier. Do be very careful with the debug mode there. It's very useful, but it's also something that I only turn it on for the duration of the change I'm making, and then I switch it back off immediately afterwards, because it lets you change stuff that it may not be safe to change. So it is important to be aware of that. So now, if I exit the spaceship, I expect to still be able to move around, and I can. Everything still works exactly as it did before, which is good. So I haven't lost any capability there. All I've done is make it that it's working a little bit more reliably, well, a little bit easier for if we're doing further updates. So, okay, that's good. I've got updates I want to make to improve things for the spaceship. So with the spaceship, we did make a bunch of changes for supporting handling gravity coming from different directions. And that definitely made it trickier for orienting and balancing the stuff with the spaceship. So what I want to actually do is I want to improve how the auto level works, make it that it can work a little bit faster, and also set up some stuff where now that we have multiple gravity sources and we're able to be moving between them, it means that it's a lot easier to get in a situation where we might be going at rapid speeds or we might be spinning around, things like of that. So what I want to be able to do is I want to actually be able to have essentially an auto braking. So I want to improve the auto leveling, and I also want to be able to have an auto braking option as well. So the auto leveling, this version worked okay for keeping it level, but we can make it better. So what we're going to do is I'm going to get, we can still call it a leveling vector, but I'm going to change this so we can go quaternion, and I want to get the rotation from our current up vector to the local gravity's up vector. So that's going to give me that rotation, and then I can get that into Euler angles. So that's going to give me a rotation that if I directly applied it, would rotate the spaceship immediately to be oriented correctly. Now, we don't want it to orient like of that. We want it to actually take time. So then now what I'm going to do is I'm going to change my approach here for these, and I'm going to get rid of these minuses. I want to keep it fairly simple. So roll happens around the z-axis, pitch happens around the x-axis in Unity. So what I would be doing, so I'm just going to order these differently. So I'm going to have leveling vector.x times by auto level, and I want to have pitch error influence, and then for the roll it'll be leveling vector.z by auto level roll error influence. So I'm then going to head up here, and I want to change. So I'm going to have a pitch and roll error influence, and I'll also put in a velocity version. And I'm going to put in some initial values for the pitch and roll error influences. So I'll get those set up in there. So that's good. And then I would add to that, we have our linked rigid body, the angular velocity x, by auto level pitch velocity. And then we would do a very similar thing here, except it'll be linked RB, angular velocity dot z, by auto level roll velocity influence, which those roll and pitch velocity influences, I do want to have a 0 to start with. I just want to check and see how well it works just purely based upon the angle error. So with those changes, we've got our initial values here. So we can test this out. And what I'm hoping and expecting to see is that I can run this and I can hover up in the air and we essentially stay level. Now see, it immediately starts spinning. And there's a reason for that, which if I debug log the leveling vector, we'll see, even before I take off from the ground, what that is. And so I'll run this, and we'll see. So even with me sitting on the ground, so I'm getting values up around near 360 degrees. So where it's saying 354, that's actually meaning minus 6 degrees. So what we need to do is we need to adjust these ranges. So I'm going to be checking if leveling vector.x is greater than 180, then leveling vector x, I subtract 360 from it. I'm going to do the same thing for y and z. And what this will do is this will mean that our leveling vector's ranges get constrained, because this then becomes less than minus 180, and we do a plus. So it's going to constrain the ranges to be between 180 and minus 180. So this is a problem. Before, an error of 6 degrees was being treated as if it was an error of 354 degrees. So we need to always make sure we adjust our values in cases like this. So good to be looking out for things like that. Otherwise, our spaceship ends up having a rough time, especially with the damage system. Even my flying's not normally that bad. So now we can see the error ranges are much more reasonable. So now if I go to hover up, can see seem to be staying somewhat level. If I move around the planet, then can see I'm generally staying level. And we can see the error values there are staying pretty low generally. Now this is where we could start to experiment with putting in some values for the velocity there, could help to potentially restrain it. So the idea with setting the velocity is it should act as a bit of a braking force on it. So with the velocity initially, what I would recommend is don't start too small with the values. Chuck in something that's large, test it with one value, and we could test just one axis, so we could just do pitch in isolation. And if that value seems to make it worse, make it more unstable, try swapping the sign of it, just to get a sense of the sign that you need. Because if the value is too high, the auto leveling becomes kind of over damped, and so that in itself can cause oscillations. So that process of just starting with a decently high value can make it a little bit quicker and easier to find good values for it. So what I'm expecting with pitch is it should stay probably even more stable, and I'm looking for, when I'm hovering, how quickly is the pitch sort of converging and stabilizing? And that's something where if it feels like it's going a lot slower, then potentially I need to adjust my values a bit. And so that seems largely unchanged. What I could potentially do then is, seeing as 10 doesn't make much of a difference, let's test 100. And I'm wanting to get a point where I see a visible effect, potentially even, and that can be a visible bad effect, is actually entirely fine. And the key is that it's having an effect. And we can see in this case, my pitch angle is oscillating either side a bunch. So that does show it's having an effect. So then I'm going to flip the sign of that and see, does that make it better or worse? If it makes it better, then it probably means my default value there should be something that's negative. And so hovering, in this case, my pitch error is decreasing. So that suggests to me that's actually probably a pretty decent value for the velocity one and that it should be negative. So the roll one, I'm going to default to making it negative as well, and a similar value. They probably should be pretty similar, I would expect. It's unlikely they should be different. And I'm looking for the roll value similarly stabilizing. And it's showing that same behavior of being much more stable. And I move around, and again, I see it stabilizing pretty quickly. So that's exactly what we want, that we have an auto level system that is able to stabilize very, very rapidly. But again, that's a setting that you could actually control and could be something that's an upgrade, for example, for the player. So that's good. We can get rid of our debug now. We don't need to be logging that out. We've got our improved auto leveling. And we should also find that the auto leveling handles things a little bit better now if we go and try and move or fly over to another planet, because it's now a bit more robust with handling changing gravity. So what I'm going to do is, because the planet is disproportionately close, I'm not going to fly too rapidly. I want to try and have it be a bit of a measured flight. And we can see it's already aligning to the new planet. So that is aligning a lot better than previously. And that then means I can come in for a much more gradual landing. That's nicely aligned with the planet. Now at this location, it's going to be experiencing gravity from both planets a little bit, because this one's also a much lighter one, but we successfully land. So the auto leveling is a little bit more refined now, which is good. That's what we wanted, was to have that be balancing a bit better. What I want to also then set up is the ability to auto brake, essentially to be able to bring us to a full stop. Because that's something where, especially when you're controlling a spaceship, it's very, very, very easy for the spaceship to just go out of control. It's very, very easy for that to happen. So having a means for essentially putting the brakes on and just being a case of, nope, I just want this to come to a full stop is really handy. So what I'm going to do is I'm going to set up auto braking. And this will be something that can be enabled. Auto braking. So I'm just trying to keep these all as features that can be turned off and on, because that makes it a little bit easier for working with. Now the auto braking, that's something that we'll take a look at how we want to set that up. So it's going to be in a similar area, but we need to, auto braking should essentially take priority over everything. That's the big thing. It should be taking a priority over everything that we have. So what I'm going to do is I'm going to adjust this. So we are already calculating our force here, but that can be the default. What I want to then check is, okay, well, if auto braking is enabled, I'm going to override that thrust force. So this is where it gets a little bit interesting. So I need to work out thrust in all different axes to apply. And so that means I need the component of my velocity along the axes that I'm applying it to, because the idea is I take my current velocity in each axis and I want to bring that to 0. So I need to get the component of the velocity along my different axes. Now, fortunately, that's pretty easy for us to be able to be working out if we need to. So what we can do is if I do a vector 3 ... and I take my velocity and then I give it a particular axis to project that along. That is going to be the component along that axis. So this is the component along the right axis. So dot product is great where you want to get what is the component of this vector along this particular axis. So I can get the right one, and then I can get my other three key ones of up and forward. So just keeping everything lined up to make it a little bit easier to see what's happening. So we get the component along each axis. Then, well, I need some force that gets applied to that, so some scale like we have with all of the error ones. So what I would do is I can multiply each of these. So I will have auto braking, and this is going to be the velocity scale essentially. So this is applying a scale factor to our current velocity. And I'm going to actually call this linear velocity scale. So linear velocity is translating us and moving us in our XYZ axes, whereas an angular velocity rotates us. So this is the linear velocity scale. Now these are going to be equivalent to these areas, but we have limits on the amount of force that can be applied, and it's quite possible that this has exceeded those limits. So I actually need to do some clamping here. So I'm going to say that a mathf clamp component right. Now this is in the horizontal plane, so this gets constrained with our max horizontal force. So we do the negative and then the positive. So then the thrust vector is equal to, we have our transform.right multiplied by that. Then we would do thrust vector, and we start to add in each of the other components. So I'm going to add in the forward next, just so it's on the same plane. And again, I'm just lining things up just because I find that if I then need to come and track down an issue or if there's an inconsistency, just makes it a little bit easier for me to do that. So then this one is up. And this one is also up. And the reason here we need to be careful is up has a different max force. So we do need to make sure we use the correct max forces with this. So that's good. That will override the value. And so I haven't done the actual rotation yet. And I won't do the rotation side yet. I just want to make it that it can essentially stop all movement for it. So it might still be rotating a ridiculous amount, but I want it to just be able to be holding the position. So auto braking, have a serialized field. Now I'm pretty confident this is going to need to be negative, and because this is giving us a thrust value, it should be similar sort of scale to our thrust values here. So I'm actually going to pick the midpoint and go for about 10,000. So then we're going to test this out. And so what should happen is once I am up in the air, I'm going to tick auto brake, and then I expect that to hold my position. So we're going to get way up in the air and then turn on auto brake. You can see speed is dropped right down. Now still a little bit of speed. If I dropped the linear velocity scale, you can see that goes up. So I might need to actually increase that even higher. Now there's still potentially a little bit of movement that might be happening there because of the forces on us, but we are essentially pretty much stopped. So minus 10,000, minus 15,000 feels about right. Could also chuck that up to even higher because it will constrain it. So if we chuck that up to minus 20,000, and then this time I'll get up similar height. Right, similar height, turn on auto braking, and pretty well stopped. We could experiment going even higher. And we could possibly go even higher again. We're probably, if we look at the rigid body, the actual movement there is pretty low. You could go even higher again, but it's probably you risk potentially it then oscillating. I think the minus 10,000 is actually sufficient. It gets us pretty well stopped there, and that's really the goal, is getting it so that if we have a scenario where we are just going at massive, 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 massive speeds like this, that there's a way for the player to be able to go, nope, stop. Now I could still be rotating at this point, and so that's something that we do need to address, is the rotation side of things. We also will have noticed that when it was applying the sort of thrust that it was doing there, it wasn't actually going and visibly firing any of the sort of thrusters there. So that's something where if we take a look at what's happening, we have these ones here that we probably need to be setting up an update for that as well. So that's something where we want to be looking at the, keeping track of the thrust vector we're actually applying is going to be a useful thing to be doing here. So the auto landing, we're going to make some changes so we update a actual thrust vector, and that thrust vector is something that we store. So here I'm going to have vector 3 current, I'll call it normalized thrust vector. And what I will be doing is, well, if we're doing this, the normalized thrust vector, if we take a look at how it's going to be normalizing it, it's going to be based upon the individual forces there. So we would have normalized thrust vector x is that divided by max h force. And we're going to do this for each of the components. So in this case, we are update the normalized thrust vector, which that is what we will have the visuals use. So I'm going to remove our one that we did have being tracked here that was just for the vertical component. So we're going to have that. Going to get rid of the other bits, and that will cause errors, which that's fine. That's actually intentional. Because what I will be looking at is that normalized one. I'm going to keep track of a previous one for it as well. So we'll have vector 3 previous, just so we can minimize the amount of times we're sending updates through to the visual side of things will be good. So we know that. These go down here. Have the update there like that. And then our changes, well, what we do is if normalized thrust vector is not equal to the previous, then we're going to make some changes here. We don't need to do that. We can move our updating of this into the loop here, like that. Then all of this is just going to be looking at our normalized thrust values. So we don't directly use the input anymore, and we use pretty much the exact same approach then for all of these. So this will just make it that it's a little bit more consistent. The visual effects there, everything is tying into the same system. So it means if we do further updates for things that apply thrust manually, that those will just work. We'll tie this into the haptics as well. So everything is tied into the same setup. And then the auto land is going to need an update here. So this is updating those Y values. Now this is something where what we could do is move the auto landing up so that the auto landing is able to actually run at this point. And that what we do is the auto land adjusts the thrust vector's Y value, or adjusts the thrust vector based upon this calculation. So that's something that we could actually be doing here. Thrust vector plus equals this. And that means the normalized one goes away. That means this goes away. Our other bits here for the auto leveling remain. But our thrust vector calculations, everything there is now a little bit more reined in. So it should mean our auto land still works. It's just going to mean that everything is working in a little bit of a different way. Now, auto land, we probably want it to actually override the thrust vector a little bit more than it currently is. So with this way we're applying the thrust vector, it actually could exceed our vertical limits for thrust if we were applying thrust ourselves at that point, which is, we want to avoid that happening. So what I need to do in that case is I need to sort of break apart the thrust vector, because being able to apply horizontal forces I think is good, but we want to get rid of the vertical side. So what I want to actually do is thrust vector. So we take a vector3 dot thrust vector with our transform dot right multiplied by transform dot right. So we're going to pretty much override the thrust vector. So it ends up becoming that plus vector3 dot with transform dot forward. So what we're doing is we are eliminating the up component. So this, remove the vertical thrust, and then the vertical thrust will only be due to auto landing. So that prevents people from sort of cheating the system a little bit and using auto land and applying thrust themselves. So this should now mean our auto landing, things like if that still work nicely, but the difference will be I can still thrust horizontally, but I can't go and apply vertical thrust. So that's going to make that work a little bit better. And then if I go up to be, so I am quite high up and moving pretty fast, and then turn on auto braking, can see reverse thrust is getting applied in the opposite direction, and there's just going to be little puffs of the thrust being applied, which is great. We've got that consistent now and in a fairly generic way. Now, it's still possible for us to end up rotating a very large amount. So we want to have our auto braking also be able to slow and stop rotations essentially. And we will eventually also make it so we can just turn on auto braking. So what I'm going to do is for the auto landing, we're calculating the thrust there. So we want to calculate a torque to apply. So the linked rigid body, the torque we're going to add. Now it's actually quite easy to calculate this. We go for our angular velocity, so x, multiplied by our auto braking, and this will be angular velocity scale. And so we do the exact same thing along each axis. Now we could potentially have different values for each axis. I think it's unlikely we would need or want to do that, but we could do that if we wanted to. So this will perform the derotation essentially. So we just need to give a suitable value for that, and that's going to rein that in. Now that's something where the value is again going to be negative because we want to take those velocities and reduce them to 0. So I'm going to start that at minus 100. That's probably a decent value for that. And so that's pretty good. The final sort of bits we want to look at then is, well, if we're doing an auto brake, we don't want to do auto leveling. So that'll be something where when we make it that you can press a key to auto brake, that actually will shut off auto leveling as well. But the rest of that looks pretty good. And what I can do is in the info here, watch the angular velocity, and what I am expecting is that when I turn on auto braking, that angular velocity, if I can get that angular velocity up to a decent value, and it's going to be a little bit tricky without knocking it into something. Actually, it might be the easiest way to potentially get a decent level if I start it again and try and actually hit into something. That should get me a decent angular velocity. So there we go. Let's turn on auto braking. And so it does manage to rein in the angular velocity, which makes it a little bit easier for me to get level. And again, that leveling process becomes a lot easier when I turn on the auto braking. So getting this having, and if I turned off auto leveling, that would actually get even more of an angle up. So if we've got auto leveling off, we can now get a pretty decent, there we go, pretty decent angular velocity happening. And we can see we are starting to spin. We can see the angles changing quite a bit. So I turn on auto braking and our angular velocities are decreasing. And we can see our rotation rates are starting to slow. It's still going to take it a little bit, and that's what should happen. We do want it to take a little bit for those to actually slow down. We could experiment with a larger value here for that sort of slowdown. So if we went for 1,000, that's going to slow it even quicker. And we can see the values are still changing, but by quite a small amount. So that makes it a lot easier for working with. So now we want to make it that that's linked up to a key. So the spaceship already has stuff like toggle auto land. So I'm actually going to duplicate that, and this is going to be toggle auto braking. And we're going to, we need another key to link that to. So we've used south, we have used west. Let's change that from the gamepad. We're going to use north for that. We use north, and then on keyboard and mouse, we'll go for B. So that's the toggle auto braking. So then we need to update our input dispatcher. So we're going to put that in here. It'll be very similar to this. So we'll have toggle. We just need to make sure we match the name exactly. So it's toggle auto braking. So we can send that message. And we go to the spaceship where we have the input set up. Then what we will have is a protected void input value. We use the exact same setup that we did here. F value is pressed. That's input value. If it's pressed and auto braking is enabled, then we can do perform auto braking. We invert it based upon whatever current value is. So that looks good. And we'll make sure this is set up similar place. So protected bool. And then in terms of how we use it, it's going to be quite similar to the auto landing. So if we are doing an auto landing, so we need to decide what takes precedence here. So if auto braking is enabled, we actually can just change that to if we are performing an auto braking. Now, if we are performing an auto braking, and actually that angular, we moved that and we put that in the wrong one. That was actually supposed to go up here. It should work a lot better for slowing the angular velocity because it would have just actually been dragged before. So if we're performing auto braking, then that also needs to stop us auto landing. So if we are not auto braking and perform auto land was requested, and we'd have the height check met. So we can't auto braking essentially takes preference over auto landing. That is also going to be the case when it comes to auto leveling, because auto leveling can be used during auto landing or can be on by default. But if we are doing our auto braking, it shouldn't actually be on. So if we are not performing auto braking and either auto level is enabled or we're doing a landing and the gravity meets the criteria, then we actually can auto level. So we're just limiting where particular ones are running, so we can't do everything all at once. So it keeps it avoiding things stomping on each other or potentially exploits where you're able to move faster than you should be able to. So what this means is I'll turn on auto braking by default, and then when I press the necessary button, so I can still make sure I can auto land. So auto landing. So that works happily, and I can toggle that off and on easily. So now testing the auto braking, which is bound to the north button. So we'll get up to a decent height and turn it on. And immediately all the thrusters fire, and it's largely trying to keep me in pretty much the exact same spot. So there'll be slight changes, but it's avoiding any major changes. So that means things like if I'm trying to then do a migration or journey to another planet, I can start heading towards that planet, and then when I get closer, I can do an auto brake, and with luck, manage to get held at a decent spot. And I can turn the auto braking off, and I'm still getting captured a little bit by the gravity, which is fine. And then I can auto land quite happily. Pick my landing spot. And just gently touch down on the other planet. So there we go. We've got improvements in being able to orient and position the spaceship. We've made it easier now for bringing in updates to the character motor, which is going to be great. That makes it easy for us keeping up to date with everything. So we've got all of the key bits updated. Main thing we want to also make sure, remember and do, because we've updated stuff in the ship, is updating the prefab. Again, just applying the changes to the script, not applying any of the mesh changes for that. But we've got our updated spaceship controller going that's now a bit more robust for positioning. We've got more options there for things we can turn off and on as well to improve that experience of being able to fly it around. Thanks folks, hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It really helps out, it's really appreciated. If you have any questions, chuck in a comment below. If you're looking for the code for the project, that is available up on GitHub. You can freely use this in any of your own projects, commercial or non-commercial ones. I've also got a link in the description to a video archive where you can find this video and all of the other ones linked there. That's something that's searchable based upon the descriptions and keywords, so it can be a really easy way of finding related ones if you're trying to. And I've also got a link there to my Patreon, so if you're looking for other ways to support the channel, then I've got that there as well. But until next time,